Hello, sir. Can you hear me?
I can hear you.
Yes, I'll just start recording. Start. Yeah, that should do it.
I'm having a capacitor. Draw for the case first.
Yes, sir. One second. I'll just connect my tablet. Yeah, okay, it's connected.
I'm having a capacitor,
yes,
and
sir.
that capacitor has got two dielectrics. One with dielectric constant K1 and the other with K2.
Yes, sir. So we do have a capacitor. That's one plate. That's the other plate. And that's
Can I get to see the larger picture? It's up to you, right, to get it to the display, right?
Yes, sir.
Could you please enlarge it?
Oh, so are you not able to see my screen? Oh.
No, not in totality, not in entirety. I
So,
would wish that takes the major space out here. Could you please change orientation?
So I don't think that's my problem. You should be able to pin my presentation to your screen.
I'm trying to pin it. Fine. Okay, fine. Go ahead, Vasudhan. Yeah.
So you find that?
Fill it with, yeah, I'm good.
Yes, sir.
Fill it with two dielectrics here, K1, yes. K2.
So this, wait 1 second, I'll just switch to a better color. Okay, so this is dielectric with constant K1. This is dielectric with constant K2. Both of these are plates, A and B, and both of them have charge plus sigma and minus sigma.
Okay, one is with D1 thickness, the other is with D2 thickness.
All right, this is D1. This is D2.
You're supposed to find charge on the interface.
Right. Charge density, right? I mean, like yeah. For example, let's call this sigma 1. Yeah. Okay. So we have to find sigma 1. Fine. So, well, I mean, we could exploit the same method we used in the last class. Draw a pillbox. If I could zoom in and use a better color, right? That's going to be my pillbox, right? And we go and we already know that the electric field is going to be in this direction. Magnitude may vary, but its direction is always going to be normal to the surface. So what we could do is just calculate the flux here, and whatever the differential is, that has to be equated to the charge. Let the electric field here be E1 and the electric field here be E2. We know that the electric field between the plates of a capacitor is given by sigma over kappa epsilon naught. So the electric field in the first one, okay, we both of us know that this is going in like this direction, so I don't think mentioning the sign here would be necessary. So I'll just say sigma over kappa 1 epsilon naught, and E2 would be sigma over kappa 2. I keep getting confused with kappa and K. Kappa 2 epsilon naught. Okay, so, and if I take this to mean my pillbox, my area vectors would be pointing this way and this way respectively. So if I were to take the dot product, E1 vector dot A1 vector, that is my A1 vector, and E1 vector dot A2 vector plus E1 dot A2. Okay, that should give me the total flux passing through that pillbox, and that can be equated to Q enclosed over epsilon naught. Okay. Okay. So right from here it's just substitution, right? So we go sigma by kappa 1 epsilon naught. Let's assume that area to be A. This is going to be negative because the dot product of two vectors in opposite directions, cosphonately, it's going to be negative, plus sigma A over kappa 2 epsilon naught. That's going to be equal to the charge enclosed. Now we call that sigma, so the charge enclosed should be sigma 1A by epsilon naught. Right, now we can just go on the cancellation spree. A's go, the epsilon nots go, right? So that leaves us with, sigma, okay, we can take a sigma common. We get 1 by kappa 2 minus 1 by kappa 1. All of that equal to sigma 1. Okay, and that's our expression for sigma 1.
Mm-hmm.
Yes, so that's the answer, right? That's...
Okay. If I wish to get a generic form here, what would you say, given to you the entire potential across the plates being V?
Okay, so the potential across the plates is V. Okay, I'll just write that as delta V.
A formulation which can be used at our dispense.
So you want to get this in terms of delta V, correct?
Yeah, that'll be a great shot in arm, right? If I'm able to formulate when I have not to go through all, but get a form which can be in direct disposition, I'll be able to use in examination at least to the mains level, correct?
Yes, sir.
So what it should be, given to you, V is the potential across the plates, potential difference.
All right. So we know to express V, right? We can write V as E1 D1 plus E2 D2.
Absolutely.
Yeah, so we can write it in that manner. Well, okay, let me just think about this. We know E1, D1, and E2, D2. Okay, let's just substitute our values in for E1 and E2. Let's see what we get. Right, we know E1 is sigma over kappa 1 epsilon naught, right? Sigma 1, sigma D1, kappa 1 epsilon naught, plus sigma D2 over kappa 2 epsilon naught. Okay, so the only problem here is like we don't have the D's involved anywhere. But E1 is equal to K1, K2.
Is to use superfluous D1, D2.
Well, as long as they're in there, I don't see any way of directly associating this with that. Although we have everything else. I mean, if you just took a sigma over epsilon naught out, this would end up looking very similar to that equation we have right there. D1 by kappa 1 plus D2 by kappa 2. It's just the D's that are, in the way. What am I missing here? Oh, well, okay. Maybe just maybe. We know that the capacitance is equal to Q over V, right? And I think I remember reading that in this scenario, right, this can be treated as a combination of two capacitors placed in serial combination with each other.
That brings me to another question, Vasudev, which I leave you as food for thought. Okay. I'm leaving with another question. Let us say that I'm having plates of the capacitor filled by two dielectrics, rather three this time. Two I have taken already, so three this time. Okay. Okay. And they are in, let's say, L shape. One is complete top, and the other half being filled by K2, K3. So I'm not able to visualize what you're saying. A quarter by K2, K3, a quarter by K2, K3, side by side, getting it? Wait, so one second, I'll just draw the parallel plates. Okay, so those are our parallel plates. What next? How are the dielectrics positioned again? Dielectric is positioned in L-shaped form. That means you're having L shape of one dielectric and the other quarter with K2.
L shape of
L shape of one dielectric and the leftover quarter with K2.
So I'm still not getting what you're saying.
Draw an L. You can draw an L.
Okay, something like this.
That ways. Yeah, fine. Oh, do. Yeah, correct. That's okay.
Okay.
This K. This is K1. Mark it K1.
Okay, that's K1. That's K2.
Yeah. Now I am to find equivalent capacitance.
Okay.
I employ two ways to you. The first way being you draw a line in continuation with the one that you have drawn, yeah, this one, and find it out. Fine?
Okay, so you're suggesting we
draw the vertical line, you extend the vertical line. That is the second arrangement.
Okay.
Okay?
Yeah.
There are two arrangements I'm getting you. You have to work on both the arrangements and let me know, are we to end up with the same or different?
Yes, sure.
And if we are ending up with a differential equation, then what explains that differential equation? Why is there a departure on answer vis-a-vis way that we are choosing? Are we going wrong somewhere on theoretical aspect? You're not to get the same answer. Let me reveal it to you. You'll get different answers.
Okay, just depending on how we consider the division, we get a different answer.
Yeah, exactly. That is what my question. That is where my concern lies.
Okay.
If you get a different answer, I don't have an argument. Sorry, same answer, I don't have an argument. If you get different answer, you have to explain yourself.
Yes.
Okay. So these are the two questions. I'm leaving both of you. Try them out. Connect at 8:30. I think I have shared with both of you the link, correct?
Yes, sir.
Yes, sir.
Right, Vasudev? You two have the link?
So
Connect 8:30. I think I have shared a click with you because that got shared with me.
So could you like send me the actual link? It's going to be hard to extract the link out of a picture.
See, the problem is that that guy is already with some repute. Okay. So he will wish not to this going to town. I should not pester on the same. Okay.
All right, so I'll just use some text recognition software.
You can do it if you are not able to, then I'll ask questions.
Sure.
Okay. Okay. Clear all your doubt, dear. Whatever is there lingering for long, the way that we are clearing, accordingly you have to clear and you are to stretch whatever you want him to get you through. You are to stretch. Okay?
Yes. Okay.
See you. Bye. Bye, both of you.
Thank you, sir. Bye, sir.